right, so here's what we're going to do. I'm going to finish up doing a few more examples from 3.2, just because we talked about them yesterday and you wrote down the rules, but I'm not sure that we actually did enough examples other than the two that I have in the notes. So I want to make sure that I go through and cover those again. Now, one of the things we talked about was we said if the bases are the same, then what's here has to be the same. So we're going to solve this just like Algebra 1. And we get an answer. And what we want to do is we want to plug it back in and check and make sure that it doesn't violate the domain rule. So if I plug 4 in here, I get a positive 4, so that's okay. And if I plug a 4 in here, I also get a positive 4. So I'm good. So my answer checks out, v equals 4. Okay. And so again, when I want to use my log properties, I need to take a look at the bases of my logs. And so if those are the same, they are, then I can set the parentheses equal to each other. And so I want to do that. And this is going to be for solving. So I'm going to bring these over and that as well, actually. And so I'm going to get n squared plus 10n plus 24 is equal to 0. And so I get n plus 6, n plus 4. So I get n equals -6 and -4. Now remember, in order for this to work, I need to plug them into my original and make sure that what was in the parentheses is not negative. So when I plug in -6, I'm going to get -36 minus 60, so -6 is out. Okay? When I plug in -4, if I plug in -4, I get -16 minus 40. It's out. So this one is going to have an answer of no solution. There's no number that is going to make that work. Okay? So when we do our algebra, we just want to double check. I've double checked. I'm getting no solution. Okay? So back to the rule. If the log base is the same, then what's in parentheses is the same. Okay? The second thing I want to make sure that we do is we know how to read our textbook. And so our book is going to say rewrite, and we want to take something that looks like a log and make it be an exponential. And so what we do is we take the base of the log and we bump it to that power, and then we set it equal to that. And I do the same thing over here. I take 11 and I bump it to that power, and I set it equal to the inside. Okay, so when you're rewriting, you're basically taking the log and you're rewriting it as an exponential. Okay, that's all you're doing. And it turns out that that is simply taking an equation, notice the equal sign, it's taking the equation and it's rewriting it from a log to an exponential. Okay, the second thing you're going to have to do is evaluate. And the way that we're going to evaluate without a calculator is we're going to use this base and we're going to convert 1/9 into some form of the number 3. So it turns out that that's what you get for 1/9. That is equal to this. This log base 3 is going to stay the same. And now I want to convert this so that it's not 1/3, but it's rather 3. So I'm going to go back to Algebra 1, and I'm going to use my laws of exponents that says I can do that. And now I'm going to use the power rule or log properties that says this is equal to -2. So my final answer is -2. I cannot do this on my calculator. I have to be able to do this. And this would be a baby step number 1 problem because I don't need to know anything but Algebra 1 to simplify that. Okay? So now I'm going to come over here and I'm going to rewrite 343 in terms of 7. So log base 7 of 7 times 7 times 7. That's really what I have. So log base 7, 7 to the 3rd. these become 1, or you could say this, that is equal to 1. So 3 times 1 is 3. Okay? So evaluate without any calculator means you have to convert this number into some form of the base. 7 in this case 3. You could do something like log base 2 of 16. So I need to convert 16 into a form of 2. So 2 to the 4th power, which my answer is just going to be 4. This goes away. Okay? I can even do that with fractions. Log base 1/2 of 1/16. So I need this to be some form of this. So the answer here is 4. Okay, you need the big thing to be some form of the little thing. Okay? All right, so now we're going to talk about section 3.3. Now, I'm going to give you a worksheet on Thursday in class. And the reason I want to give you a worksheet Thursday in class is because there's certain examples that I really want you to practice, okay? I don't want you to do everything in your book, but there's some that I want to make sure that you get to do, okay? All right, so your goals for today or tonight while you're watching this is to be able to use the change of base formula, which is just that, it's a formula. And then the second thing you need to do is apply log properties to either expand or condense logs. Now, one of the benefits to expanding or condensing logs is that we can use our log properties. And so that becomes super important when we're doing this, okay? So let's take a look at this. It says, let A and B and X be real numbers, okay, which means we're done with imaginary. This only works in the real world. And it can't be 1, right? Because what's the log of 1? It's 0. So it's really important that we don't have 0 in our denominator. That's really all we're saying, right? We're still saying that rule from back in elementary school, denominator cannot be 0. That's all this nonsense is saying, okay? And so it turns out this. Here's the pattern. You take this big thing and you put it on top. You take the little thing and you put it on bottom. Now, this works for 2 reasons. And the main reason that we want to do it is because our calculator has 2 buttons. It has a log button and it has an ln button. Those are the only 2 it has. So this log that's on our calculator is log base 10. This natural log is log base e. Those are the only 2 bases that our calculator can do. Now, there are some new calculators that will do more, but for us, we want to make sure we know how to do the change of base, okay? And so it turns out that here's your formula. So the big number goes on top. The little number goes on bottom. And this b here can be anything I want. It can be log base 10, which is what this is. There's an imaginary 10 written there. Or it can be this one, which really, remember, natural log is really log base e. Okay, so either one of those is good. And so if you have a special calculator, you can convert that. You can use any number you want there. It doesn't matter so long as it is the same. Okay, log 2 over something. Log 2 over something. Okay, this would have to be a 2 and a 2. 10 and a 10. E and an E. Okay, this is on our calculator and this is on our calculator. So I want you to pull out your calculator and I want you to have it next to you. Pause me right now if you need to, but get your calculator out and I want you to write down these 2 problems. Okay, so pause the video, write down these 2 problems. Okay, so you should have paused me. I'm now going to talk. What I'm going to do is I'm just taking the big one and I'm putting it on top, and I'm taking the little one and I'm putting it on bottom. Now this is going to be the log button on my calculator, and this is going to be the natural log button, or as Miss Wynn likes to say, the in button. And what I want to do now, I'm going to pull up my calculator, and I'm actually going to enter the log of 25 divided by the log of 4. Now, I want you to look at this when we do it. I'm going to get rid of all of this stuff. I want to clear everything out. So here's what I'm going to do. I'm going to say the log of 25, close parentheses, divided by the log of 4, close the parentheses. Now, keep in mind, I don't want the log of 25 divided by 4. I want the log of 25 divided by the log of 4. So now I hit enter, and I get an answer. So I'm going to leave that here for a second, because I'm trying to prove something at this point, because I want you to believe that no matter what I'm telling you about the math, if I do good math, the math is always true. It will always work. So now what I want you to do is I want to put your natural log button. So push that. And we're going to do the same exact thing. The natural log of 25, close parentheses, divided by the natural log of 4, close parentheses. Oh, Miss Collins, it would help if you slowed down and let your calculator catch up. There we go. Sorry. So they look the same, only one is log base 10 and the other one is log base E, or natural log. And so now I want to do, and I want to hit enter. And what do you see? What do you notice about those two answers? Tell me what you notice. Okay? You should be telling me, oh my gosh, I can't believe it, Miss Collins. That is the same answer. It is exactly the same. And the point is, it doesn't matter whether you like the log button better or if you like natural log better. Okay? Let's go ahead and do it with this one now. Log of 12 over log of 2. Pause me. I want you to try this on your calculator. You don't need me. Over the natural log of 2. We're going to come back to the calculator, and we're going to hit log 12, close parentheses, divided by the log of 2, close parentheses, and I get an answer. Excuse me. And then if I do the natural log of 12 divided by the natural log of 2, and then I get holy guacamole. Look at that. Same exact answer. So it doesn't matter whether you use ln or log, okay? Choose whichever button you like the best. My preference is natural log, just because that's what we use in calculus more times than not, so I like to go with natural log. There's no rule that says you have to do it my way. All right, so what we want to do now is use our 3 log properties. Okay, now I made mention of this one earlier. And the reason is they talked about the log properties canceling earlier. So this is written differently earlier, but I'm going to call it the power rule. And what I want you to notice here is that what was in the exponent gets to come out front. Okay, what was in the exponent gets to come down front. The second thing is if the base, and this is in your notes earlier as well, and the u are the same, so if a equals u, then that's 1. Log base 2 of 2, guess what? 1. We did these examples in class on Wednesday. Log base 7, nope, let's do a different number. Log base 2 million of 2 million, 1. Okay, it doesn't matter. If they're not the same, I can just leave it, okay? And then I can use change of base formula. So here's the rule. Product property means if what's inside is being multiplied, then I can use an addition symbol. The quotient property says if what I'm taking the log of is being divided, I can separate them with a minus sign. Here's the important piece. Log base A stays the same in both cases. Log base A stays the same in both cases. All right, so let's expand these. So I get log base 4 of 5. I'm going to rewrite it like this, because then I can see that it's going to expand nicely. And now I'm going to use the power rule. So log base 4 of 5 plus 3 log base 4 of x plus log base 4 of y. Okay, that's it. We're done. I have taken something that looked small and I have expanded it. Okay, now I'm going to let you do B on your own, and I will check that when you come in on Thursday. I'm now going to do C. So division means minus. Okay, multiplication means plus. And power means bring it out front. Notice I'm doing it step by step because I want you to see how that works. So the division sign equates to a minus sign. The multiplication equates to a plus. And the power equates to a constant out front. Now I want you to try D, and I will check that when you come into class on Thursday. Putting it back together is the exact same thing. The only difference is we're going to take something that's long and we're going to make it shorter. So constants get put back as exponents. So step 1. The second thing, plus really means multiply. And now I'm done. Okay, so we're working backwards. We're working backwards. So I'm going to hit this one for you. That comes up. That comes up. So this is natural log of x minus 4 to the 4th minus the natural log of x squared. The second thing, minus equates to a fraction. The first thing goes on top. The second thing goes on bottom. Okay? So now I want you to do it, and I want you to make sure you notice 2 things. When it was already in parentheses, I left it alone. You do not make that be division. Okay? You do not make that be division. Notice that this is a natural log minus a natural log. Then I can convert it to division. Okay, I want you to do C and D and bring those to class on Thursday. Okay, Thursday. So I'm now checking 4 examples when you come to class on Thursday. Here's your problem set. Notice I want you to do the odd ones on the given sets there. And then on 81 to 84, I want you to do all of them. Okay? When you come to class on Thursday, we are going to be finishing this problem set, and I have a handout for you. The handout that I'm going to give you, we're actually going to be able to finish class on Friday, because Friday is rally day, homecoming Friday. I'm not going to present a lesson, okay? I am going to have you watch a video on Thursday night for 3.4, but I'm not delivering a lesson in class on Friday, okay? So, happy homework time.